Hey, sixth graders, Mrs. Zimmerman here, and today we have a brand new lesson on factoring. So take out your paper, take out your pencil, and we're going to get started. I'm going to share my screen with you here. And this lesson today is very similar to distributive property. It's just the opposite. So if you remember in distributive property, you have something like this, right? The A times B plus C. And you would distribute. You would say A times B, A times C, and that's how you would get AB plus AC. Today with factoring, we're doing the opposite. We're going to start over here and turn it into something that looks like the distributive property. So I'm going to head to the front and we'll get started. So let's take our first example, okay? 18 plus 30. Now, the directions say that we are going to factor using the greatest common factor. Okay, greatest common factor. Do you remember that? Oh boy, let's just off to the side. So if I have 18 and 30, what is the biggest number that goes into both of them? Well, let's do our factor trees. 9 and 2. 3 and 3. Okay, 30, 3 and 10, circle my prime numbers, and I'm good to go. All right, now let's look. I have 2 times 3 times 3, and I have 2 times 3 times 5. So these 2's and these 3's, 2 times 3 equals 6. So 6 is the greatest common factor of 18 and 30. So over here, I'm going to do 6 with a pair of parentheses. And all I have to do is divide. What is 18 divided by 6? 3. Then we have a plus sign, so I'm going to do plus. And what's 30 divided by 6? 5. So I put a 5. And that's it. I just factored. Okay, let's check our work. 6 times 3 plus 5. Well, what's 6 times 3? 18 plus, what's 6 times 5? 30. Does that match what we started with? Yes, it does. So I know I'm done. Okay? We're just going to keep moving right along and we're going to do a bunch of examples. So now I have 9 and 15. So I'm going to come over here and do my factor trees, 9 and 15. 3 and 3 are both prime. And 3 and 5. Okay, so 3 times 3, 3 times 5, the biggest number they have in common is 3. So I'm going to go back to my problem. In order to factor it, I just write 3 with parentheses and a plus sign. What's 9 divided by 3? 3. What's 15 divided by 3? 5. So am I done? Yes. Next one, 20 minus 12. Greatest common factor of 20 and 12. Here we go. Remember, it doesn't matter what numbers you use because no matter what, at the end, we will all end up with the same thing. And all I do is circle the prime numbers and list them out, smallest to largest. Circle the pairs. My pairs become a 2. These pairs become a 2. What's 2 times 2? 4. So the greatest common factor for 20 and 12 is 4. All right. 20 divided by 4 is 5. This time I have a subtraction, so you need to pay attention to that. And 20 divided by 4 is 3. All right. Let's do another one. Okay, here we go. 30 minus 20. Now, sometimes you might be able to do the factoring, the greatest common factor in your head. If you want to, you can come off to the side and do your factor trees and find the greatest common factor, but sometimes you just might know it in your head. Like, for example, I know that the greatest common factor for 30 and 20 is 10. There's nothing bigger than 10 that goes into both of them. So I'm not going to do the trees. I know it's 10. So I'm just going to start with 10 and write my parentheses. The important thing here is that you remember it has to be the greatest common number. Okay? So if, 5 goes into 30 and 20, but I can't use 5 because it's not the greatest one. So you need to think about that. If you're not sure if the number that you're thinking of is the biggest one, just do the factor trees real quick, and you'll find out that in this case it's 10. So 30 divided by 10 is 3. Subtraction, 20 divided by 10 is 2. Now again, I know we have it on the last, but if you wanted to check your work, just distribute and see if you get the same thing. 10 times 3 is 30. Minus 10 times 2, which is 20. They match. Okay, let's do another one. Some bigger numbers. 60 and 45. So I have 60 and I have 45. Let's just break it down. What goes into 60? 6 and 10, right? And then I have 3 and 2. And 10, 5, 2. Those are my prime numbers. Okay, circle what they have in common would be a 3 and a 5. 3 times 5 is 15. So that's the number I'm going to put out front. 15 in parentheses. 15. So now we're going to take 60 divided by 15. And you might be able to do that in the top of your head. If you can't, well, let's just do some multiplying. What if I did 15 times 4? 4 times 5 is 20. Carry the 2. 60. So 4 will work. If you know that in your head, again, you could have just done that in your head. But with little bigger numbers, sometimes you have to work off to the side. And then 45 divided by 15 is 3. Okay, I think hopefully you're getting the hang of this. You can go back and watch these again if you need to, but the next thing we're going to move on is to factoring algebraic expressions. So this time, our expression is going to have a variable. So for example, we have 3x plus 42. The first thing, same, factor trees. 3 is prime, so I'm just going to circle it right away. And then I do 42, which I could do 6 and 7, and 3 and 2. So what's the biggest number they have in common? I don't even have to list them out. It's 3, right? Yeah. So I'm going to do 3 with my parentheses. Now let's think. 3x divided by 3. 3 divided by 3 is 1, so just 1x. The x has to stay in the parentheses. Okay, and then we add, what's 42 divided by 3? If you need to do the math off to the side, you can, but I know that's 14. So let's look at this here, okay? Let's check our work. I have 3 times 1x plus 14. 3 times 1x is going to be 3x plus 3 times 14 is 42. So is that going to work? Yes. Let's do a few more like this, okay? I have 7x plus 49. So I'm going to start with my trees, 7 and 49. That's prime. And we got a lot of 7s. So the biggest number they have in common is 7. So I'm going to write 7 with parentheses. Now, 7x divided by 7 is going to be 1x. Do I really even need to write the 1? No, right? I can just do x. It's the same thing. Plus, what's 49 divided by 7? 7. And that's it. We're doing the exact same thing as before, just now we're going to have some letters involved, some variables. Okay, 8y plus 14. So I've got 8, and I have 14. Do my trees. And I end up with my prime numbers. So, list them out. Wait, nope. The 7 goes on the next one. And then 2 times 7. 2's are my pairs, so what's my greatest common factor? 2. So I'm going to put that out front. I leave the variable. Now, what's 8y divided by 2? All you have to do here is what's 8 divided by 2? 4, and bring down the y. Plus, what's 14 divided by 2? 7. So that is your final answer. Let's do another one, 8 and 44. Okay. Again, if you know this off the top of your head, you don't have to do the factor trees, but I just want to double check and make sure. So I'm going to do it all out. Okay, my greatest common factors are here and here. So then I have 2 times 2, which is 4. So 8y divided by 4. 8 divided by 4 is 2. Bring down the y. Minus 44 divided by 4 is 11. Let's try one more just to make sure we got it. 26x minus 13. Okay, so I have 26 and I have 13. 13's prime, I'm just going to circle it. And 26, the only numbers I can multiply are 2 and 13. So this one's easy. 13 is obviously the GCF. So 26x divided by 13. 26 divided by 13 is 2. Minus, what about this one? Ooh, 13 divided by 13? That's just 1. You just put a 1 there. Okay? Now, I'm going to head back to my desk. All right, hopefully that made some sense to you. Go back and watch it whenever you need to, and I'll see you next time.